Server-side template injection, or SSTI, is a serious security vulnerability. Attackers can use it to execute malicious code on web servers. They inject malicious code into website templates. This allows them to take control of the server. Protecting against SSTI is crucial for any organization. We will also examine real-life examples to understand the impact of SSTI. SSTI vulnerabilities occur when user input is not properly sanitized. Web applications use server-side templates to generate dynamic content. Attackers can inject malicious code if input is not validated. This code is then executed by the server, leading to SSTI vulnerabilities. SSTI arises from the failure to distinguish between data and code. Attackers exploit SSTI vulnerabilities by injecting malicious code into vulnerable templates. They use various techniques to identify and exploit these vulnerabilities. One common technique is to test for SSTI by injecting special characters and expressions. If the server responds with errors or unexpected output, it might indicate a vulnerability. Attackers often use fuzzing tools to automate this process. These tools send numerous payloads to the target application, trying to trigger an SSTI vulnerability. Once a vulnerability is identified, attackers can then craft payloads to execute arbitrary code on the server. They might use techniques like code injection and command injection to gain control of the server. Section 4. A deep dive into SSTI exploitation methods. SSTI exploitation methods vary depending on the template engine used. In Jinja 2, attackers inject code using double curly braces. In Twig, they use a different syntax. Payloads can steal data, install backdoors, or launch attacks. Section 5. Preventing SSTI Best Practices and Solutions. Preventing SSTI vulnerabilities requires a multifaceted approach that involves secure coding practices, input validation, and regular security testing. One of the most effective ways to prevent SSTI is to avoid using user input directly in templates. Instead, developers should use template engine-specific methods to render user data safely. Input validation is another crucial aspect of SSTI prevention. All user input should be validated and sanitized to remove any potentially malicious characters or code. Regular security testing, including penetration testing and vulnerability scanning, is essential for identifying and mitigating SSTI vulnerabilities. Automated tools can help identify common SSTI patterns, while manual testing can uncover more sophisticated attacks. Section 6. Real-world SSTI. Examples and lessons learned. Real-world examples of SSTI vulnerabilities highlight the severe consequences of these attacks and the importance of addressing them. In 2019, a critical SSTI vulnerability was discovered in a popular content management system. This vulnerability allowed attackers to execute arbitrary code on vulnerable websites, potentially compromising millions of websites. In another instance, a major technology company suffered a data breach due to an SSTI vulnerability in one of its web applications. Attackers were able to exploit the vulnerability to gain access to sensitive user data. These examples demonstrate that SSTI vulnerabilities are not theoretical threats, but real-world risks that can have significant financial, reputational, and legal consequences. The importance of addressing SSTI. SSTI is a serious security vulnerability with devastating consequences. Attackers can exploit SSTI to execute code, steal data, and control servers. Understanding SSTI is crucial for cybersecurity professionals. Implement secure coding, regular testing, and stay informed to mitigate risks.